Hi, welcome to everyone's favourite segment, Mailbag. I hope you had a good Christmas and you might even be watching this in the new year, so happy new year. Let's get into it. We've got a Kickstarter, time sensitive, and 1st of January. Oh, I better hurry. Thank you very much from Zepto Bits. By the way, my Kickstarter is, I just got the money in yesterday, as if you follow me on Twitter, you would have seen, and now I've got to spend it all by buying the stock. Well, I already have bought some stock, and it's coming in. I'm not going to, bit miffed, I'm not going to actually meet my promised deadline of December. It was very close, but they're like sending like today or tomorrow or something, so I just like, there's just been little delays here and there, and it's, what can you do? Anyway, so yeah, it might be at least a few days late, maybe a week late or something, depending. Anyway, by the way, yes, I am, you've no doubt seen in the previous video that I am going away for a good lot of January. No, I'm not running away with the Kickstarter money. I am going away, but I'm going to have some guest videos. There's been a lot of submissions for those, and I will be choosing some choice videos to show on the channel. There's going to be some really good ones, so stick around for that. I hope you enjoy it. Thank you very much. Oh, look. Thumbs up using the Dave logo, I guess. What do you call it? I don't know. The letter-based thing, which there's a few people using the letter-based concept. If you haven't seen it, I'll link it in at the end of this video if I remember. I'm sending you 2 optically isolated USB UART adapters. Thank you very much, Emil Johnson from Zepto. Jeez, they're thin. There's nothing in them. Geez, opto-isolated USB UART adapters. Very handy if you need to isolate. Cool. We'll take, oh yeah, they're both, yeah. They've just got different USB connectors on it, and they've got my logo. Thank you very much. Let's take a look at them. As it turns out, Emil is currently over 500% funded on the Kickstarter. Fantastic, and I'll link it in down below if you want to jump on the bandwagon, and I recommend you do, because these things are incredibly useful, and being optically isolated, of course, nice isolation slots there, excellent. 3.3 and 5.5 volt jumper, nice. And of course you power it from the external supply, so you got to hook up an extra cable in there to do it, but you can't blow up either your computer or your circuit with any ground loops or anything like that. So valuable to have one of these in your parts bin, not parts bin, your, I don't know, equipment shelf or whatnot. And there's not much on it. There's a couple of opto isolators and a USB to UART adapter, and that's about all she wrote. Yeah, it's got the proper isolation shots, slots, and everything else, and of course, the open source. Hey, it's different. There's an extra D in there. The D's not on that one. Oh, what? Anyway, oops. Anyway, that's cool. Check it out. And you can either get one with the micro or the old style type, which is just big and rugged when you're hanging the thing off a bloody cable like I'm doing. If I'm hooking it up to a, you know, some serial pins on a product to extract the firmware from it or whatnot, then, you know, having a little micro USB is a bit dicky. One of these big A types is the go. Ah, there you go. It is supposed to have the D, the design notes principle of operation, by the way, which is excellent, because in the datasheet here, there's a full schematic for those playing along at home. There's not much to it, but very nice quick start guide, and then a table of contents and summary. So avoid ground loops, all that sort of jazz. Neato. Works anywhere up to 2 meg board, and I/O levels from 1.8 to 5 volts. Thank you very much, person unknown from Melbourne, here in Australia, not Austria. Let's take a look. Okay, here we go. By the way, videos coming up. Yeah, with the Kickstarter and all the fulfillment crap I've got to deal with for that, it's limiting my time at the moment, but I do hope to do probably another debunking video before I go away, plus maybe another one or something like that. I'm not sure. I don't plan that far ahead, usually. Here's something to cut open. Okay, let's cut it open. Cool. Whoa. Looks like serious bit of kit. Caution, static sensitive type. It's an Assman. American ass. Check this out. It's obviously designed to go in the rack because there's a lot of wasted space on that puppy. But it looks like some sort of ovenized, oven crystal oscillator. Cool. 2.048 meg. Cool. We'll do a quick, it's all the can is completely soldered together. That's a pain in the butt. Here's something to cut open. 2.048 megahertz crystal oven. It came from a system, and I still don't know what the DAG 100 announcement was saved to. EEPROM played back when anyone rang the line that were connected. Anyway, there's a multiplicity of timing units. God, it sounds like a straight out of a patent application, doesn't it? Timing information path extracted. Pretty comprehensive stuff on how this timing board is tied into the system and works. So yeah, this is for some telecoms thing or whatnot. Man, this is just nuts. As I said, there's not a huge amount on it, and yes, we do have the schematic, hang on. But anyway, here's the VCXO module down here, and it's basically you just apply power and Bob's your uncle, right? Gets the output, and then you've just got some output drivers here, which then just drive 100 ohm balanced lines to spread across the rack or the system or whatever it is they're powering. So nothing fancy there at all, and that's all she wrote on here. So there you go. Got some voltage regulation. It's all very neat and tidy. I love how they heat shrinked it and cable tied it there. Beautiful. And there's your output drivers down there. And it has to be this long because it's designed to go into a rack. So for those playing along at home, there's the data. Vectron Labs. Made in the United States of America. And it's all sealed inside. We may have to blast. Now, I could try and get the soldering iron on there, of course, but you need a huge, grunty soldering iron because it's a massive heatsink. So it's easier just to get in there with a screwdriver and just crack the solder open. It's a bit medieval, but we don't want to reuse this anyway, so, Well, inside an ovenized oscillator, it's not going to be spectacular. It's just going to be some foam because it needs insulation. It's some sort of, hard cell foam type insulation. And there's just going to be a regular boring, large crystal oscillator module, which is carefully hand-selected and manufactured by Nude Virgins, of course, and then tweaked and calibrated by, Greybeard Nude Virgins. And a heater coil, of course, and then feedback to maintain the... maintain... Oh, hello. To maintain the temperature, of course, because it's temperature controlled. Oh, there we go. Really old school. Look at that. Oh, I see a precision... That looks like a precision resistor down there. Very low Temco resistor. The black one. And then, of course, there's some of our hard cell foam insulation. And, yeah, they've got it taped. Like the entire core is just taped down in there. So we've just got the controller board. And then there'll be an ovenized, there'll be like an oven element, a heater element down in there. And the crystal. And then it's just some temperature feedback. All right, there we go. We've extracted the package. That was an adjustment screw. So that was what the screw was in the back of physically in the back end of the case, there was a screw. So you could get in there and tweak it. So can we cut into this puppy? It's not like a physics package in a rubidium oscillator. It's just a... Oh, there we go. Jeez. Wonder what the date on this would be. I'm thinking sometime in the 80s. Crack it open. Oh, there we go. Geez, that's actually more serious than what I oh, damn. I think I just might have broke some wires or something. It's really fascinating. Wow. Look at that. Is that just electrical tape? I think that's just electrical tape. Ugh. I gotta go clean this up. This is horrible. Anyway, you can see that the temperature of this thing is just like burned inside that. So anyway, it contained it. It did its job. It probably worked for like 20 years. At, you know, these things might operate at, you know, 50, 60 degrees or something like that. You want them to operate above the maximum ambient temperature, which might be, say, you know, 45 or, you know, 50 inside a rack, or, you know, something like that. So yeah, that could have been operating at, I don't know, could have been operating at 70, 80 degrees. Who knows? And if that was electrical tape, well, it's kind of, well, no, I don't know. What is it? It's like paint or something? Actually, look at that. Wires wrapped around the case. Is that the heating element? That could be the heating element. Wow. Some sort of nichrome resistance wire or whatnot. And wow, I just thought they were like ridges in electrical tape. That's what it looked like at first glance. And then I poked it with a knife and went, like I tried to find a seam to peel it off. But no, they're actually, you know, they're all on there, wound a bit, how you doing? But I got to screw off the end and ta-da! Oh, we're in like Flynn. Wow, look at that. So, yep. So we got two wires. Well, okay. Got two going in there. Could one be a sensor? Could that be a sensor perhaps? One of them's the coil, one of them's the sensor? Don't know, but there you go. There's the oscillator circuit. It's, you know, probably some variation of a coal pits or something like that. Liberal application of the Celastic down in there, and ta-da, I told you, it's just a regular Joe Bloggs. Well, it's not a regular Joe Bloggs crystal, as I said. It's manufactured and tweaked and hand selected by grey-bearded nude virgins, and there you go. Got 79 degrees C written on it. 12 puff for those playing along at home. And it's a Y4200, so that'd be a 2.048 megahertz crystal, I assume. I don't think they've got a divide by, oh, they might have a divide by 2 on there, who knows? But yeah, no, that's probably a 2.048 megahertz crystal. Really good one. As I said, hand selected, hand cut, everything else hand measured, and probably almost certainly aged in and everything else. And we've got ourselves a trimmer cap. There you go, there's the trimmer cap in the end of it. Get in there from outside the case and go with your tongue at the right angle, and you can trim your 2.048 megahertz oscillator. Of course, the whole idea of an oven-controlled oscillator, why they go to this sort of trouble to actually keep it at a particular temperature, is because crystals are inherently very stable when you keep them at a particular temperature. Even your crap ones, you know, one you buy for 10 cents at the Shenzhen market can be very good if you keep it at exactly the same temperature and dry voltage, and then you don't shock it, you don't move it, you don't orient it, because I've done a video, I might have to link it in, about the orientation of the crystal. You can actually use them as gravity detectors, and I've actually demonstrated that principle. So as long as you don't touch it, they're generally pretty good. But of course, this one would be super selected, super aged, and then you've got age in and all sorts of characteristics like that, which go into it, of course. But yeah, I've done like a lot of characterization of the stability, the long-term stability of crystal oscillator modules. That was part of my job back in the day, and it's a very interesting thing how if you just go like that on the side of it, you can effectively reset the drift characteristic of a particular crystal. It's really fascinating. So any sort of shock or vibration or anything like that. But there you go. That's an ovenized oscillator with the heater element on the outside and a temperature sensor, and they just, you know, they have a feedback loop and keep that controlled at, by what looks like, 79 degrees C. And by having that actually written on there, 79C, they've obviously, that's what it was, you know, tested at and aged at or whatever. And that's probably what they're running at in here. So I don't know what the temperature variation, you know, you try to keep it within, say, you know, half a degree or something like that. If you generally, you know, at a couple of degrees, then, you know, wobbles all over the place. No, you're going to get output stability is going to be dependent upon the temperature. So it's going to drift with the temperature. So the more accurately you can control the temperature, the more stable your crystal is. So that's basically how it works. Cool. Old school ovenized oscillator. Awesome. Now let's have a quick look at the DAG 100, the ass man. DAG 1's brilliant. Anyway, I like the pushable indicators here. And this is supposedly, is that a speaker on the front monitor? Yes, it is. And some volume there. So this is a rack mount voice recording thing apparently. And there you go. We've got ourselves a line isolation transformer on the back by the looks of it. Let's crack it open. I guess that's pretty much what you'd expect here. Speaker PCB mounted, so it just, I thought it was mounted on the front panel, but it's not. And we've got little, is that a little amp? Is it? I don't know. I can't read that. I can't read this stuff on the camcorder screen anymore. Ridiculous. Anyway, we've got a nice DC to DC converter. Oh, we can salvage that one. No worries. Oh, made in Germany. Sweet. And we've got ourselves a power amp there, but everything else is 4000 series CMOS. Except basically for these two puppies up here, MOSTEC. Anyway, we have date codes like, you know, early 80s stuff happening here, 86, mid, yeah, 86. But check out, this is an Intel D2912. That's a PCM filter chip. And there's a MOSTEC, there's a blast from the past. That's an MK5156, and that's a PCM codec. So we've got our PCM codec and our PCM filter, but where is the EEPROM that was talked about for storing this? What's that? I can only presume that that thing, which has got like L01, the rest is just the date code, and it's socketed. Don't know why the 4093 is socketed there, but anyway, that one I assume must be the serial PROM chip that holds the recorded message. Must be. There's nothing else on here. There's nothing on the other side of the board. That's it. Hi to all my Romanian viewers. This one you're no doubt familiar with. I've had it a couple of times on the blog, and sorry I haven't, I've already opened this because I've actually been using it for like a month, and those on the forum and Twitter would have seen this already. It's Radu Moderson's new environmental monitor, the A3. He's previously done the radiation monitor, but this one is the do-all, end-all kitchen sink model. It's a complete environmental monitor. It does radiation, formaldehyde, particulates, 2.5 micron particulates, does temperature, pressure, I'm forgetting some stuff. Anyway, air quality monitor as well as radiation. It's awesome. So let's take a quick look at it, and I've been running this for a month at my lab, and let's have a look at some data. Cool. So this is Radu's new environmental monitor A3. It comes in different types. So this is the Ethernet interface one, but I also have the Wi-Fi interface version, and both of them work very well. And here's inside of it, we've got the laser scanning particulate sensor here, which has a little scanning laser in it, and it's got a little port on the back where it sucks in the air, of course, and a little micro fan inside there, so it sucks it in. The airflow just comes through over here and out the other side. It's not very noisy at all. I've got one running at home in the back room, and it, you know, you can, like in the middle of the night, you can just hear it, so you wouldn't want to, you know, have it on your bedside table or something like that, but it's certainly not loud. And of course we've got our Geiger Muller tube in there, and then we've got our formaldehyde sensor here and our CO2 sensor down here, and of course these are all factory calibrated and characterized and whatnot. And Radu did send me a characterization sheet on one of these that has been independently lab certified and all that sort of stuff, and there's a couple of whatnots on the bottom. And that puppy right down in there is the Bosch VOC sensor, and you can see the slots around there. It's just on the outlet of the fan, so so it's well placed, well designed, just to get the airflow directly over that. Awesome. And we'll have a quick look at the software interface, which we've seen before, but there's also this new cool dashboard view, which is worth checking out. It gives you an like a summary, an overlay summary of all the different sensors inside this thing for different time spans. And here's the data for my lab. Isn't it great? I'll link it in down below if you want to check out the live data. Oh, and we've got a little microphone down in there as well because it also measures noise. It must be doing some sort of like, average in, heavy duty average in and stuff like that, because you don't want knocks and bangs of doors to, really register on this thing. So that it'll all be done in software, no doubt. So Radu's done a fantastic job developing this over the years, and I'm not aware of any really major competing solution for this, and it's not cheap. But if you're after comprehensive environmental monitoring for your location or a remote location or whatnot, then this thing is pretty much the duck's guts, I think. Check it out. Thank you very much, Silen, Silent V, Stoyanov. I'm from Bulgaria. Hi to all my Bulgarian viewers. Let's check out what's inside. Is that it? No, what's it? Fancy VU meter. Turn it on. Give a power to the USB port, 5 to 20 volts. Oh, right. Okay. Is it a project? Silen's done. So here's the VU meter. I'm actually not sure if Silen actually produces and manufactures this or not. Anyway, I'll link it in down below, sketchremote.com, schremote.com. So let's power it on and see what happens. Hey, hello, for EEVblog by sketchremote.com. Oh, there it is. Ah, I like the decay on the... Hello? No microphone built in. Oh, at least have one on the board, I reckon, and have a jumper link that you can actually connect to it. Anyway, is that an SD card under there? I think that's an SD card slot. Updating the firmware, perhaps. Well, it turns out this thing's a real comprehensive beastie, and I've hooked it up to the PC, but I got a connection error, but I was warned that I was supposed to install the drivers, but I have a problem installing the drivers, so I don't know. So I'd really like to play around with this thing some more, because it does have some cool visualization stuff in the software, but I don't know, it's probably a pebcac. I'm doing something wrong with the drivers, but I tried for a bit. I'm not going to spend any more time on it at this stage, but it does look, suffice to say, it does look very cool. And yes, that is, you can see the touch screen in there, so let's have a look. View modes. Oh, maybe we can set it up in here. Here we go. There we go. Maybe we don't... Oh, analog VU meter. Look at that. Maybe we don't have to use the software. That's cool, but the software, I think, allows us to do more stuff or whatnot. But there you go. How do we get view options? There we go. And you can set up your channels and stuff like that. It supports left and right stuff. I'm just feeding it in from the Rode mic here, but back. There you go. Anyway, I think it's really quite cool, so I'll link it in down below if you want to check it out. Apparently, it does claim on the website it does like oscilloscope, type stuff as well. So, it's all just in software, basically. Of course, it'll only be like audio type bandwidth, but isn't that hunky-dory? Not sure if this has a name on it, but it's from Finland. Hi to all my Finnish viewers. Let's crack this one open and see. It's a bit mangled from the old Finnish post. Or was that done locally here? I don't know. But yeah, it has seen better days, this package. Got some solder wick. Got some old parts. Magna card. Oh, more solder wick. Thank you very much. I can always do with solder wick. It's just got some... What is it? So I've got some random miscellaneous parts. I replaced the main board for... I still don't know what a Magna Card 200 is. To Google, but look, they've got the LCD driver under there. And presumably, it looks like it's just a... maybe is it a, a 7106 panel driver or whatnot. But we've got ourselves the micro on there. What's that puppy? That's an NECD 8749. That's like an 8080 compatible chip. So there you go, like old school stuff. NAIS relay, but what does it do? No, that just uses a Philips PCF 2112 LCD display controller. That's all it is. Just dedicated controller. It's got external, external cap, 2 caps. What are they? You know, runs like an RC oscillator, perhaps, or something like that. So we don't have any knowledge of this at all. Anyone? Bueller? Okay, does anyone know what that is? Looks like some form of spark gap, perhaps? Once again, Bueller? Hi to all my viewers in the old dart, in particular M. Tandy, great last name, from Hatfield. In the UK, of course, which is the old dart. The UK is the United Kingdom. The capital? No, it's not the, like, what do you call it? The capital of the Commonwealth? The head of the Commonwealth? Whatever. Australia's part of the Commonwealth thing. Dear Dave, really enjoyed the show. Thank you very much. Enclosed, please find a transmitter and receiver, a J electronic radio safe, rated wireless emergency stop? What? Removed from a warehouse automation system. Oh, right, okay. So you can just have an emergency stop button. It's not an emergency stop button. Unfortunately, both of us, feel free to take them apart. What you find inside may surprise us. Ooh. So Michael reckons what we're about to find inside one of these industrial controllers may surprise us. Anyway, yeah, they're wireless. No wireless antenna, like antenna built in, I guess. Yep. Oh, I completely missed the coax B and C on there, on the front of the bloody unit. Oh, I was like, where's the antenna? Where's Wally? Geez, right in front of me. Kind of like that that construction. So let's open up a bit more and see what we've got in there. A little daughter board. Yeah, it's going to use like an off-the-shelf wireless module because it's already like, you know, certified and everything else. So they're not going to dick around doing that themselves because these industrial controllers, price point really doesn't matter. And I really like the interconnection system. Check it out here. They've got these like card edge contact things, which then you might be able to see the contacts along the boards in there. And then when that just clips together, that makes contact on there. Dual edge, is it? No, it's single-sided. You can have a contact on either side of the board there. But that is just a really nice bit of engineering. Take note of something like that. That is just brilliant. You know, the board's in there, no wiring, no nothing, just clip it on, and then it interconnects with all these screw terminals on here. Fantastic. Aha, one of my favorite construction techniques. I'm sure I've mentioned this in various videos. Yeah, I might have mentioned like the Raspberry Pi cluster or something like that. By the way, yeah, maybe I'll get around to it one day. I don't know. But yeah, you cut slots in the board like that and then just put the board over and then just solder board to board. And they've made a cube out of that. They put some Celastic on there for good measure. Maybe just to hold in place while they solder the thing. And because that wouldn't be supplying any structural, you know, integrity while after you've soldered those things on. And that is a really cheap and simple method for creating a cube board construction like that. That is really jazzy. I like it. Anyway, we've got some input protection or output protection resistors or whatnot. Geez, I have to desolder all that to get it apart. Anyway, it's not huge. We're more interested in the physical construction details of this thing rather than going in, having a look at the individual chips and whatnot. It couldn't really give a rat's ass part. You know, they got some optos and things like that for driving, you know, their various outputs, inputs and outputs. So, you know, some sort of alarm system driving some relay. And as I said, just some sort of off-the-shelf module for the comms. And there you go. As I said, that could be an off-the-shelf module, or they've got it designed and certified by someone else. Although, you know, it looks pretty customy to me. So anyway, they could have subcontracted that out. Little mask ROM, mask flash or whatever ROM. You know, it's fairly recent, this thing. And just all your requisite opto drivers and stuff like that. But that's cool. I like that. And of course, Hitano. Can't say I'm familiar with Hitano brand. Anyway, but that is awesome construction. I love that. So that's the surprise. It wasn't a huge amount of surprise to me, but if you've seen or opened these types of industrial controllers before, then you know, you would have seen similar types of construction before. But just being able to have, you know, just those blocks. Look, I mean, there's no, apart from the, of course, you've got to have the coax in there for the antenna, but apart from that, there is no wiring at all inside that thing. Brilliant. Hi to all my viewers in San Jose. I love San Jose. Oscar Weagle. Not sure if not sure if it's a silent G or not. Anyway, from O-Drive Robotics. Cool. So, robotics type stuff, I'm guessing. Go the gaffer tape. Gaffer tape for the win. Let's slice and dice her open. I'm sending you a demo of a project I've been working on for the past 3 years. Wow. An open source, low cost servo motor for robotics. Is it like a Kickstarter-y type thing? Jeez, lots of stuff in here. Wow. Oh, that's like a propeller. That's a serious propeller attachment for what I'm guessing is a very serious motor controller. Wow, awesome. All right, well, I won't bother unwrapping. Let's take a look. Whoa, this is heavy. We have a serious bit of kit here for you motor aficionados. Oh, look at that. We've got ourselves a nice looking rotary encoder on there. Wow. So I've got a rotary encoder attached to the motor. That's very interesting. We'll have a read of why he's doing that. Some kind of optimization thing or something. And look, they're obviously designed, and that looks like a, you know, a model plane propeller type interface. And this is like probably a model plane, you know, a big model plane grade motor on this thing. Wow. Let's read the note. And check out this driver board. Whoa. This is looks to be handmade, this one. Got ourselves a genuine bodge wire on there too, going across there. And this is some serious business. Check out the heat sinks on the probably the H-bridge driver trannies down in there. And what sort of processor is that? Some sort of army type thing. It's always an ARM thing these days, isn't it? It's all the rage with the young kiddies. This looks grunty, like kilowatt grunty. Wow. Let's read the note. Hi Dave, I'm sending you a demo of a project I've been working on for the last 3 years, an open source low cost servo motor controller for robotics. This lowers the price and barrier to entry to using high performance motor control for hobbyists and startups. Industrial servo motor electronics are very expensive, I'm sure they are, even though I'm not in the field. I can pretty much guarantee they are. Usually $300 per axis, wow, sometimes more. At the same time, there are very inexpensive brushless motors from China, originally for hobby remote control airplanes, yep, and the drive electronics for those are also dirt cheap. From my experience working at ABB Robotics, aha, I know that the precision control is all in the software, and the marginal cost of the software, yep, is effectively free. So there had to be a way to make a cheap but still precise version of an industrial servo motor controller, and it turns out I was right. It's called the O-Drive. How cheap? The motor, $30 for a 1600 watt motor. The encoder is $10 for a resolution of 2400 counts per rev. Wow, cool. So demo instructions: clamp the motor test jigs to a table. Important. Oh dear. I don't know if I got clamps here in the lab, but that's more at home kind of thing. Use caution. This system can put out greater than 3 kilowatts. Well, I don't even have a 3 kilowatt supply here. My main supply is only 2.4 kilowatts. Connected 12 to 20 volt. Apply power. Don't touch the motor during the calibration sequence. Aha! The first 6 seconds. So when it boots up, all the software is in the magic. Does it, I presume that it, can you, like, take the rotary encoder off later and then just drive that particular motor, and then you've got the properties of that particular motor? I'm assuming. Is that how it works? Because you don't want to leave the encoder. Do you want to, you know, because if you have to leave the encoder on when the thing's running, then that's a bit inconvenient, because, like, where do you stick your encoder at that point? We've got it on the shaft here, but yeah, you could have something coming off, of course, but that's not nearly as convenient. So I'm going to assume that it maybe does some calibration and stores it for that particular motor, perhaps. That'd be cool. Tell you what I don't like is the screw terminals here just soldered onto one half of there. Like maybe they're designed for bigger ones, because they're massive holes on there, bigger bolt hole ones or something. I'm not sure, but then he's just soldered in the pin-based ones there. It's a bit how you doing. But I'm sure this is just like a, you know, well, he says it's a prototype, doesn't he? Yes, a demo of a project yet. So, you know, I'm sure that production ones wouldn't have this. Anyway, it's designed to drive 2 motors and an auxiliary thing here, which we've just got hooked up to a dummy load resistor. Don't know why. And it turns out I did actually have some clamps here. Not terrific, but I'm sure they're only going to spin up for like these 6 seconds that he said it uses to calibrate this. So it should be more than good enough. Fingers crossed if I got the polarity correct. Black, yep, negative, positive, I think so. Apply, I've got set to 15 volts maximum. Let's power it up. Hello? Beeping. Ah, they're slowly turning. It's doing its calibration. I expected them to go but, is that it? Didn't even do a full rotation. Oh, okay. Maybe you can explain in the comments why it's, like I would have expected a full rotational calibration, but maybe just the small steps is enough. Oh, I can feel the backlash on that if I try and move it. Anyway, I can hook it up to a PC and send serial commands. Okay, I've got the PC hooked up here. It's a 115K board, and I'm going to type in, try this command. I have no idea what it does, but let's give it a whirl. Hang on. Press enter. Didn't do anything. So I'm not sure why that's working, but thank you very much, Oscar from odriverobotics.com. I'll link it in down below for all you motor aficionados who are into motor controllers. I know that, well, David is. He's done his own motor controllers and stuff like that. Open source one. Check it out. And of course he works for ABB Robotics, so probably knows what he's doing. So this could be a good way to get a real precise industrial servo motor using a cheap brushless motor and an encoder. I don't think it works, as I mentioned before, that you take the encoder off and it calibrates it for that particular motor. I think you need the rotary encoder on there, but gee, yeah, I don't know, but I want to see it like spin up fast. Got it clamped down and everything. Anyway, check it out, odriverobotics.com. This could be cool. Thank you very much, Edward Frost from Canada, New York. Somewhere in New York. I already opened this one because it didn't have Mailbag on it, and I thought it was... I haven't actually looked at it, but then I realised, it's probably a Mailbag or something, so let's have a look. Oh, it's a coil. Dear Dave, greetings. I pulled this unique item out of a light dim 110 volt. Remove the shrink wrap coil to see what it was. Could you identify what it is called and how does it work? Mailbaggy. Terrific. That's the new name of the segment. Mailbaggy. Mail badge. Something like that. Anyway, Edward asks a very interesting question. He found this inside a light dimmer circuit, and it had shrink wrap over the top, and he wondered what it was and what it's called and how it works. Well, let's take a look at it, shall we? Now, anyone with any real basic component knowledge of electronics should know that this is an inductor. But if you're a beginner, of course, you're not going to know what this is. It's basically just a coil of wire wrapped around a ferrite core, and that creates an inductor. You don't need the ferrite core, but the ferrite core actually helps concentrate the magnetic field. And I won't go into inductors, but they basically store energy in their magnetic field, and then you can store that and then release it. Now, usually in an electronic dimmer circuit, you don't need an inductor for the functionality of it. It uses a triac in there typically, and you don't actually need the inductor. So what's the inductor in there for? I'll put up a typical circuit. I'll pull one up on Google Images or whatever, so full credit to whoever did this circuit. And it's basically, you can use this without the inductor. You can simply short it out and it'll still work exactly the same. So what's the inductor actually in there for? Well, it's actually working as what's called a choke, and it suppresses radiated RFI or radio frequency interference coming back out from the triac switching element in the circuit itself. And that's the purpose of this particular inductor here. But this particular inductor is actually rather interesting. Look, here at the end, the wire, like it goes around, it goes, bloop, 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 you can follow it all the way through, all the way through, all the way with LBJ, and it comes to the end, and then it wraps back around and goes back. Now, this is actually what's called a bifilar wound inductor, and what that means is that it basically just loops back on itself, and the return path follows the path coming in. So if the current's flowing in this direction up this wire right at the end, the current flows back in the other direction right next to it, so the magnetic field created by that current effectively cancels itself out as it goes all the way with LBJ right along there, in and back out. So what that does is it effectively gives this inductor, which normally has self-inductance because it's an inductor, it effectively gives it a self-inductance of 0 because the inductance cancels out itself, but it still has the property of storing and releasing a magnetic field. And then in this particular case, we'd have to get into the difference between common mode and differential mode inductance and that sort of thing. But suffice it to say, a bifilar wound inductor like this has effective inductance in the common mode, but not in a differential mode configuration. So that's why it's useful for suppressing RFI interference. So thank you very much, Edward. That is an interesting question, and the answer is, surprisingly, this does nothing to the operation of the actual light dimmer itself. But it's a nice engineering touch to have this in there to reduce all the switching, basically the switching noise coming from the switching triac element inside there. And yeah, no, if you bought it from China and they're on eBay for $1 delivered, your light dimmer, it's probably not going to have one of these because that's just extra component cost, and then it just spews out, radiates out, and via conductive mode, all this switching interference. So that's why a good one will have one of these installed. I think this one's been sitting here for a while. Sorry, M. Pritchard from Powys in the UK again, the old dart once again. So let's check it out. It is. Hi, Dave enclosed the device that has been sitting in his attic for at least a decade doing bugger all. United States patent. Yeah. 21st century automotive automotive protection. Electro shield anode. Rust protector. One of those rust protector thingamabobs. Sacrificial anode, basically. They're a sacrificial anode type thing. There's not much in them. So my apologies to fellow YouTuber Ain't Big, Ain't Clever, who I'll link in down below and at the end of this video, who has actually done a video on this electro shield remote anode bullshit. Yeah, can you smell it? I can too. And he's gone to the effort to reverse engineer the circuit on this, so we can just, maybe, can we crack it open? Is it already opened? I'm going to stab my hand here, aren't I? That won't be pretty on camera. But basically, there's nothing wrong with anode protection on cars and boats and other things. They do actually work, but they're oh, God, doesn't spring off. Screw in there or something? Anyway, they are sacrificial anodes, whereas this is an electronic woo-woo device, and it's got LEDs that tell you which anode is, like, you know, utter. Oh, there we go. It's a spring. There you go. Oh, they got a bloody. What is that woo-woo? Why have they got that sort of? What is that coil doing in there? That is the remote end anode. Why? Like, what? That. This is absolute. Oh, there we go. Yep, there's the trick. And we've got more woo-woo bullshit coil inside here. And let's flip this out. And anyway, I won't reverse engineer that, but there's no sacrificial element at all that actually gets eaten away. So let's have a quick look at the circuit here. What do we got? We've got, is that a 555? Got to have a 555 timer, of course, because it's got to have a LED that flashes to pretend it's actually doing something. Look, they're both in series. Anode 1 and Anode 2 are in series, so it doesn't matter whether you got 1 or 2 anodes. I don't know how you have multiple anodes, whatever. And it's, look, it's just powered from the input. We've got a diode over there. Sorry, reverse diode protection. Well, at least they did something. And then just a 7809 voltage regulator power in the 555 timer. So that's got nothing to do at all with anything. So it just flashes. It's just a LED flasher. That's all it damn well is. And then here we've got two 78L05s just driving the output through our woo-woo coil there, going to the other side. So it basically is just like you're connecting up the power to run at a small amount of whatever amount of current you're doing from, like, what? No, this is, like, how is this going to do jack all, like hooking a battery up to your car at one end and just expecting it to do something? Where's the sacrificial element? This is complete and utter rubbish. We've got another woo-woo ring down here. And, like, it's just ridiculous. What? No, I don't get it. If you can explain how this magic woo-woo works as a like a sacrificial anode or prevents rust protection on your car or boat or whatnot, then leave it in the comments. But that smells like complete and utter woo-woo bullshit to me. Thanks ain't big, ain't clever. I'll link in his video down below. Haven't watched the whole thing yet, but I'm sure it's hilarious. He exposes this thing, and yeah. Wah, 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 wah. Catch you next time.